In this video, I'm going to talk about controlling the advertisement of labels via LDP or Label Distribution Protocol. LDP lets you control the advertisement of labels. You can configure LDP to advertise or not to advertise certain labels to certain LDP peers. What does this mean? Okay, let's check it. Look at this scenario. In this scenario, we have 5 routers and some prefixes. Okay, this is our scenario. And you know that, for example, in R1's routing table, we have these subnets quad 1 /32 and then 10.120/24, and then because we have routing protocol, for example, OSPF in this scenario, we have 10.230/24 and then 10.340/24, again 10.450/24, and finally quad 5/32. These are the contents of the routing table of R1. And you know that R1 and also R2 and also R3, R4 and R5 should have the same prefixes in their routing table by default. Because of that, in routing table of R2 and R3 and, for example, R4 and finally R5, we have the same routing table, same prefixes in the routing table, R1, R2, and then R3, and then R4, and finally R5. And as I explained before in the previous videos, in MPL, when you're enabling MPLS in this scenario, every router should generate a label for all of the networks. For example, R1 should generate a label, maybe 100 for the networks in its routing table. 2 routes are connected to the R1. Because of that, for quad 1 it chooses null, for 10.120 it chooses null, but for 10.230 maybe it chooses 100, and 10.340 101, and again 102, and finally for quad 5 103. And you know that every router should choose or generate labels and then advertise these labels to its peer, to its LDP peer. Okay, for example, R1 should send all of this binding IP address or prefix to label binding. Okay, all of this binding with LDP binding message to R2. Because of that, R2 finally has all of the label binding of R1 and also all of the label binding of R3. Again, R3 finally has all of the label binding of R2 and then R4, and R4 has label binding of R3 and R5, and finally R5 has label binding of R4. R1 also has label binding of R2. You know this. In some cases, we don't want to a router advertise all of its labels to its peer. For example, you will understand in MPLS VPN course in future that routers don't need to learn the links, the inside of service provider links subnets R1, R2, R3, and R4 and R5. Maybe this is a service provider network, and R1 is PE. This means provider edge, and also R5 is a PE, provider edge, and R2, R3, and R4 P routers means core routers, or provider routers. Okay, look at here. You will understand that in this scenario, R1 and R2 don't need to learn the subnets that inside of the provider, don't need to understand or learn the labels for these subnets. Why? We will talk about this in MPLS VPN course, but for now, only it's sufficient that you know that, for example, R1 has a loopback interface on it, and R5 also has loopback interface on it, okay? And only routes that R1 should learn label for it is quad 5. And also R5 only routes that need to learn is quad 1. And again, R2, R3, and R4. This means that I don't need to R1 sends the labels for other networks, for 10 networks, okay, to the R2. I want to filter it. Look at here. R1 by default send all of these 6 label binding to R2. But in many cases, you don't need to advertise all of the label binding. Why? We will talk about this in its courses. In the many courses, in the many topics, you will understand that you don't need to advertise every label binding to your neighbor. Because of that, we want to filter some of this label binding, and we don't want to advertise this label bindings to a router. This means that we can control the advertisement of labels via LDP. This means LDP filtering. Okay, let's talk about this in this scenario. Look at first this scenario. I previously enabled routing protocol and addressing all of the IP interfaces, and after that enabling the interfaces. Now the scenario doesn't have MPLS enabled, okay, doesn't have MPLS, and I want to run MPLS on this scenario with IGP config. Look at here in R1, show MPLS LDP near neighbor. We don't have MPLS enabled, and conf-d router OSPF1, okay, MPLS LDP auto config in R1, and then R2 en conf-d router OSPF1 MPLS LDP auto config. And again, now we have a neighborship between R1 and R2. Again in R3 en conf-d router OSPF1 MPLS LDP auto config. Finally R4, after R4 we should go to R5 router OSPF1 MPLS LDP auto config, and then R5 en conf-d router OSPF1 MPLS LDP auto config. Let's check the result first. Now we have a neighborship between R1 and R2. LDP neighborship show MPLS LDP neighbor. Yes, we have neighborship with the R2, okay, and then in R2 show MPLS LDP neighbor. We have neighborship with R1 and also R3, and again R3 in R3 show MPLS LDP neighbor, okay. We have neighborship with router 2 and router 4, and also in router 4 show MPLS LDP neighbor. We have neighborship with router 3 and 5, and finally in router 5 show MPLS LDP neighbor, okay. It's better to use the easier router ID. For example, you can use this command MPLS LDP in R1 LDP router ID loopback 0, for example, force, okay. This changed the router ID of R1 to quad 1, but in R1 as you can see, the router ID previously is quad 1, but I forced it, okay. In R2 also you can change router ID. Look at here, MPLS LDP router ID. You can change it to an IP address of an interface. Maybe you can configure a loopback interface and change the router ID to the IP address of loopback. Okay, let's delve into the controlling the advertisement of labels via LDP. In R1, I want to see the lib or label information